Hello everyone, my name is Soujanya and I am going to present our work titled SmokingOpp, Detecting Smoking Opportunity Context Using Mobile Sensors. I would like to thank NIH, NSF and all the co-authors for their helpful contributions towards the development of this work. Impulsive adverse behaviors are those which are performed as unplanned reactions to internal or external stimuli and may have negative consequences. A few examples of impulsive adverse behaviors are binge eating, suicide attempts, smoking lapse, road rage, binge drinking, and gambling. Several of these impulsive adverse behaviors can be potentially addressed by ubiquitous technologies. One of the most interesting applications of ubiquitous computing is to facilitate the delivery of interventions before the occurrence of impulsive adverse behaviors so as to delay or prevent them from happening. In order to do that, it is important to detect the predictors of such behaviors, some of which are the internal states such as stress, bipolar disorder, or craving, while others are the external cues or contexts that are conducive to such behaviors, such as seeing others smoke at a smoking spot may lead to a smoking lapse, while being in the bar with your friends may lead to binge drinking. While several works have been done for the continuous detection of mental states, real-time detection of these external cues from mobile sensors is still an open problem. In this work, we develop a framework for automated detection of environmental contexts that are conducive to adverse behaviors. Formally, we define the environmental cues for an adverse behavior as a spatio-behavioral context that is ripe for the occurrence of such behaviors. We term them as opportunity context as the automated detection of such contexts gives us the opportunity to deliver novel sensor-triggered interventions. Next, we propose that an opportunity context is created when there is an absence of inhibitors and presence of inducers. We present the characterizations of several impulsive behaviors. For example, opportunity context of smoking lapse is created when a person is at a place where smoking is allowed and cigarettes are available to that person. In this work, we specifically developed the SmokingOpp model to detect the smoking opportunity contexts. For developing the SmokingOpp model, we utilize location traces from GPS sensors and activity detected from the accelerometer sensors, as both of these sensors are easily available on smartphones and smartwatches. Since GPS and activity are continuous data streams, the first task is to define the assessment windows where the smoking opportunity context does not change. We observe that smoking opportunity context may change when a person moves from one location to another, or in the given location, the person can just step outdoor to change the smoking opportunity context. Based on these observations, we develop event-based windows specifically based on change in location and change in activity states at a given location. Next, we compute various spatiotemporal features from the assessment windows. First, we describe the development of smoking spots as a novel feature which can be of independent utility to the research community. We use GPS data and real-time smoking detection to identify personal and general smoking spots where people can usually smoke or can see others smoking. We supplement this with detection of indoor versus outdoor and temporal features such as the time of day and time since visit to a cigarette point of sale, which encodes the frequency of visitation to a cigarette point of sale. For model training purposes, we collected data from 90 newly abstinent smokers in a 2-week-long smoking cessation study, in which the first 4 days was the pre-quit period when the participants were regular smokers, and the last 10 days was the post-quit period when the participants were trying to remain abstinent. In total, we collected more than 15 million GPS points, 13,000 hours of activity data, and 3,400 self-reports. Next, for the purpose of assigning labels to the assessment windows, we utilize the self-reported responses of cigarette availability and smoking allowance. For that, first we use Granger causality to show evidence that smoking allowance and cigarette availability can predict future smoking. Then, we use these items to construct the binary levels of smoking opportunity context. Finally, we trained several supervised machine learning models and validated them using leave one subject out cross-validation. We report that logistic regression-based SmokingOpp model can detect high versus low smoking opportunity context with a recall of 79.82 and F1 of 74.3. In this work, we defined the concept of opportunity context for impulsive adverse behaviors and provided several examples. However, we developed the SmokingOpp model only for the case of smoking lapse, but we hope that our framework will motivate the development of opportunity context models for other impulsive behaviors such as suicide attempts, binge drinking, binge eating, and others. Next, in our work, we utilized indirect measures such as the location and activity transitions to detect the dynamic changes in smoking opportunity context. However, in the future, more direct measures such as smart eyeglasses can be used to detect these contexts. This can be an interesting first-person vision problem. Finally, to establish the clinical utility of the SmokingOpp model in the management of at-risk situations of smoking lapse, randomized controlled trials can be designed to trigger and evaluate the efficacy of just-in-time mobile interventions based on the detection of smoking opportunity contexts. Thank you very much.